I want to tell you about a few hours I spent comparing two versions of the same document. Not a piece of fiction, not a newspaper article. Official NASA cartographic documentation of the lunar surface. Two versions of the same region, released days apart, in 1969. I stumbled onto this by accident. I was looking for something else entirely, reading technical reports about the orbital photography program carried out by the Lunar Orbiter series between 1966 and 1967. It was a systematic mapping program, 5 unmanned spacecraft photographing the lunar surface from orbit to prepare data for selecting landing sites. The images exist. They've been digitized and are partially accessible through the Lunar and Planetary Institute in Houston, which manages NASA's Lunar Mission Archive. And in several of them, at specific locations on specific orbital passes, there are details that in the subsequent official maps of those same areas are either absent or accompanied by shifted coordinates. Not large shifts, small ones, small enough to explain as a navigation data correction, large enough that an object that was at one set of coordinates ends up at another, or doesn't show up anywhere. I spent a long time asking myself whether this could be a technical artifact of the imaging system, or an error in early navigation data. It could be. Those explanations exist, and they're not without merit. But there are several specific cases where they work less well than they should, and that's what this video is about. Before I get into specific images, I want to explain what the Lunar Orbiter program actually was, because its archives matter in ways that go well beyond historical interest. Between August 1966 and August 1967, NASA launched 5 unmanned spacecraft in the Lunar Orbiter series. Their sole purpose was to photograph the lunar surface to identify safe landing sites for future crewed missions. This was an engineering task, not scientific research in any broad sense. They needed maps, accurate ones, reliable ones. The 5 spacecraft collectively photographed approximately 99% of the lunar surface. The imaging system used photographic film that was developed directly on board the spacecraft and scanned for radio transmission back to Earth. Each spacecraft carried 2 cameras, a wide-angle lens with a resolution of around 8 meters per pixel at standard operating altitude, and a telephoto lens that at minimum orbital altitude, during a small number of specifically planned low passes, achieved resolution of around 1 meter. That wasn't standard operating mode. Those were targeted images of specific areas of interest for landing site selection. The original film reels were held in various NASA archives. In 2008, a group of volunteers with NASA support began the LOIRP, the Lunar Orbiter Image Recovery Project, to restore the original analog recordings using modern equipment. They achieved image quality significantly better than what had been available when the material was first processed in the 1960s. The restored images are published. They're in open access, and it's the comparison between those restored images and the official maps and coordinate data released by NASA during the Apollo missions that opened questions I haven't been able to close with standard explanations. Space navigation in the 1960s was significantly less precise than it is today. That's important context that any honest treatment of this subject has to acknowledge. Determining accurate coordinates for objects on the lunar surface from orbital imagery of that period depended on several factors: the precision of the spacecraft's known orbit, the optical characteristics of the cameras, the altitude of the pass, and mathematical models of the lunar geoid that in 1966 were far less refined than they are now. Errors of several hundred meters when pinpointing locations from lunar orbiter imagery are not an anomaly. That was the expected technical reality of the time. I understand that. I accept it. But here is what that reality doesn't fully explain. When two versions of a map covering the same area, released days apart by the same agency, show the same object at different coordinates, the standard explanation is that one version was corrected based on more accurate data. That's logical. That's standard cartographic procedure. But that same procedure, even by the standards of the 1960s, calls for the correction to be accompanied by at least a minimal technical notation, a version number, a reference to the source of the updated data, a revision date. In several cases I examined, that notation is absent. The version with shifted coordinates simply replaces the previous one. The coordinates have moved, the object has shifted. No explanation is given. That is not proof of deliberate concealment, but it is a departure from the minimum documentation standard that was applied to cartographic materials of that period in other contexts, and its absence here requires an explanation. Let me move to a specific case, because abstract arguments about coordinate discrepancies are easy to dismiss, and a concrete object with concrete data gives something to hold on to. Uourt Crater sits in the central region of the lunar nearside, close to the 0 meridian and 0 latitude. That's not an incidental location. It was traditionally used as the reference point for the lunar coordinate system, a methodologically significant position on any lunar map. The crater and its surrounding area were photographed in detail by Lunar Orbiter 2 in November 1966, during a dedicated low-altitude pass designed to produce high-resolution imagery. The frames from that pass are catalogued in the archive, LO-2-61H, LO-2-62H, and several adjacent frames, and they're accessible through the online archive at the Lunar and Planetary Institute. In 1968, William Blair, a photo interpretation specialist at Boeing, which was working under contract to NASA, was examining those specific frames as part of his technical work analyzing imagery for the program. Blair prepared an internal technical memorandum in which he describes several objects in the Uourt area as having geometric characteristics atypical of natural terrain. Regular forms, repeating patterns, symmetry not consistent with cratering or volcanic origin. His professional language was precise. This was someone who looked at aerial photographs as a professional instrument and described what he saw in the terms of his discipline. The memorandum exists. It is referenced in several works on the history of the Apollo program, including materials held in the archives of the Smithsonian National Air and Space Museum. NASA's official response to Blair's memorandum is documented in correspondence from that period as noted, without initiating any additional study of the objects he described. Blair, in an interview given several years later and cited in several publications on the program's history, described the outcome of his memorandum not as a scientific investigation of the objects, but as a revision of internal guidelines about which observations were to be formally documented through official channels. He did his job. The system changed the rules of his job. That is a direct account from someone who worked inside the system, and it describes not a scientific rebuttal of his observations, but an administrative response to them. This is where Apollo 11 landed on July 20th, 1969. The site was selected partly on the basis of Lunar Orbiter 2 and Lunar Orbiter 5 imagery. By the time of the landing, it was considered one of the most thoroughly documented areas of the lunar surface. Images of this region exist in large numbers and in good quality for that era. Between 2008 and 2011, as the LOIRP project was restoring original Lunar Orbiter film using modern equipment, several researchers working with the restored imagery of the Western Sea of Tranquility published observations about details that had not been distinguishable in the 1960s wide-angle frames, but became visible in the restored telephoto frames. Specifically, researchers Keith Laney and Nancy Evans, two of the principal contributors to the LOIRP project, whose names appear in the project's public materials, noted in informal commentary accompanying the published restored images that several objects in the vicinity of approximate coordinates 0.7 degrees north, 23.5 degrees east, have geometry that under standard geological interpretation requires explanation. They weren't making a sensational claim, they were describing an observation. Those objects are present on restored frame LO2 frame 162H, which is in open access and which anyone can examine directly through the Lunar and Planetary Institute archive. I checked those coordinates against official NASA lunar maps issued during the Apollo program. In one version of the cartographic sheet covering that area, the coordinates for that section are shifted relative to an earlier version of the same sheet by approximately 400 meters. 400 meters, within the expected range of navigational error, but the shift occurred between two versions of the same sheet released within a few weeks of each other, with no technical notation indicating a correction, and the objects that were at one location in the restored images appear at a different location in the later version of the map. I want to be precise about what Apollo astronauts actually said, and what they didn't say, on the record. Because this subject has accumulated an enormous amount of fabricated quotes and context-stripped claims that I need to separate from what this video actually rests on. Neil Armstrong, Buzz Aldrin, and the other Apollo astronauts did not make public statements about observing structures of non-human origin on the lunar surface. That's a fact, and it needs to be stated directly. Most of the quotes widely attributed to astronauts in this context are either taken out of context or simply invented. That is not what this video is built on. The transcripts of communications between Apollo crews and Houston are published to a very high degree of completeness, through the NASA Technical Report Server, through the Apollo Flight Journal, maintained by Eric Jones, through specialized archives. These are open materials, and I want to name them as such plainly. But here is what I found in those open materials that I couldn't explain through standard procedure. In several specific episodes, including Apollo 10 transcripts from May 22, 1969, during an orbital pass over the western Sea of Tranquility, and Apollo 11 transcripts from July 19, 1969, during the orbital holding period before the descent, crew members described visual observations of the surface using language that, under standard operating procedure, should have prompted a series of follow-up questions from Houston controllers. The standard protocol for any unusual visual observation calls for it to be documented through a series of clarifying questions: bearing, observation angle, apparent size, character of the object. In these specific episodes, the follow-up questions did not come. The controller moved to the next item on the schedule. I understand this can be explained by the tight timeline and operational priorities. Houston controllers worked to a dense schedule, and not every observation warranted immediate clarification. That's a possible explanation. But in the official post-mission reports for these flights, documents that summarized everything significant observed during the mission, these specific transcript episodes are either absent or described in language so general that the specific content of the exchange cannot be recovered from it. I'm not saying this proves anything specific. I'm saying the discrepancy between what is recorded in the open transcripts and what entered the official record is itself something that requires explanation. There is one region of the lunar surface that deserves a separate discussion in this context: the far side of the Moon. Until October 1959, when the Soviet probe Luna 3 returned the first images of the far side, humanity had no idea what it looked like. Since then it has been photographed many times, including detailed coverage by the Lunar Orbiter spacecraft. But there is no direct radio contact with the far side surface from Earth. The Moon blocks the signal. Any crewed mission to the far side requires a relay satellite in orbit. No Apollo mission landed on the far side. The official explanation is the communications and navigation challenges involved. That explanation is technically sound, and I accept it. But here is something I find harder to accept without further explanation. In the Lunar Orbiter Archive for far-side coverage, several regions carry the notation "data not available" or "resolution insufficient." Most such notations in the archive have straightforward technical explanations: camera malfunctions, inconsistencies in the onboard film development process, data transmission errors. These were standard events in any 1960s space program, and I accept them as the explanation for the majority of such notations. But in several specific cases, including a series of Lunar Orbiter 4 frames from orbital pass 4042 over a region near coordinates 160 degrees east, 18 degrees north, resolution notations appear on frames that, according to the flight documentation for that same pass, were acquired under the same parameters as adjacent frames in the same series that carry no such notations and have acceptable quality. The flight documentation for this specific pass has survived and is partially accessible through the NASA Technical Report Server. It records orbital parameters, imaging altitude, camera settings. It does not explain the difference in quality between adjacent frames from the same series. Technical explanations remain possible. Film is sensitive to rapid temperature fluctuations. The chemical developing process could have produced uneven results. All of those are possible. But in the available technical documentation, I found no specific explanation for these specific frames with these specific notations. They are simply there, and they are there exactly where they are. In 1960, 6 years before the Lunar Orbiter program began, NASA commissioned a study from the Brookings Institution, one of the most respected policy research organizations in the United States. The document's official title is Proposed Studies on the Implications of Peaceful Space Activities for Human Affairs. It was completed and delivered to NASA in December 1960. It exists. It is published. It can be found in NASA's archives and in the Library of Congress. It contains a section titled Implications of a Discovery of Extraterrestrial Life or Intelligence. This is not a fringe source. It is an official analytical document commissioned by NASA itself from an institution with an unimpeachable academic reputation. In that section, the authors, researchers at the Brookings Institution, working under the direction of Donald Michael, directly address the question of how to handle information about the potential discovery of artificial objects or evidence of extraterrestrial intelligence. Their conclusion was clearly stated. Disclosure of such information would require careful prior analysis of its social consequences, and it was possible that knowledge of the existence of such objects would have to be restricted to those best able to determine whether to withhold, announce, or release such a discovery. That is a direct quotation from an official document commissioned by NASA and delivered to the agency in 1960, 6 years before Lunar Orbiter began photographing the lunar surface. I am not claiming this report was the instruction manual followed when processing orbiter imagery. I am saying that inside NASA there existed an officially commissioned and officially received document in which a protocol of restricted access for a specific category of information was formally articulated, and that document preceded the Lunar Orbiter program by 6 years. What happened with Blair's memorandum, an administrative response instead of a scientific investigation, is entirely consistent with the logic of the protocol described in the Brookings report. That doesn't prove a connection. It establishes that such a connection was institutionally possible. I want to close the review of the evidence with what is happening now, because this is not only a story about the 1960s, and the current data adds a dimension to it that didn't exist before. In 2009, NASA launched the Lunar Reconnaissance Orbiter, the LRO, a modern spacecraft equipped with cameras whose resolution is an order of magnitude better than the lunar orbiter cameras of the 1960s. The LRO's narrow-angle camera, the LRO-CNAC, at optimal imaging conditions, from an altitude of around 50 kilometers, delivers resolution of approximately 0.5 meter per pixel. That is significantly better than any standard lunar orbiter imagery. The LRO is still active. Its images are in open access through NASA's Planetary Data System server. This is an enormous dataset, and it is studied not only by official researchers, but by thousands of people around the world with access to these images. Among them are several, and I verified their publications, who independently examined LRO imagery of areas that come up in the earlier discussion of lunar orbiter anomalies. Specifically, the Eucurt crater area is covered in detail by LRO frames M104311-715 and M104318-871, published in 2010. In those frames, the objects in the area Blair described in 1968 are physically present and distinguishable at sufficient magnification. That does not mean their explanation falls outside standard geology. The lunar surface contains a great variety of structures, and many of them, at certain lighting angles and imaging geometries, can appear geometrically regular without being so. But it does mean the following. The objects Blair described in 1968 physically exist on the surface. They are visible in modern imagery at modern resolution. They can be examined right now without any archival request by opening the NASA Planetary Data System and entering the frame numbers I just named. And the question of why their coordinates in early official documents differ from their coordinates in the images, that question can today be asked with a precision that didn't exist in 1968, because we now have modern data to compare against. A systematic comparison has not been done, not because the data isn't there, because the question that comparison would formally raise has not been formulated by any funded research program. The Lunar Orbiter program and its archive exist and are accessible through the Lunar and Planetary Institute. The LOIRP restoration project is complete and the restored images are published. LO2 frame 162H with the objects in the Western Sea of Tranquility is in open access. William Blair's technical memorandum from Boeing describing geometric anomalies in the Eucurt area exists and is referenced in Smithsonian Institution materials. The 1960 Brookings report commissioned by NASA, with its section on protocols for handling information about the potential discovery of artificial objects, is published and available in the Library of Congress. LRO frames M1043-11715 and M1043-18871 covering the Eucurt area are in open access through the NASA Planetary Data System. The coordinate discrepancies between versions of the cartographic sheets are verifiable through direct comparison of accessible documents. These are facts of different weight. None of them individually proves what you may be thinking as you listen to this. But there is one person I want to end with. William Blair. A photo interpretation specialist, a man who was paid specifically to look at images and report what was in them. In 1968, he looked at LO2 frames of the Eucurt area. He wrote a memorandum using the professional language of his discipline. He described what he saw, geometry that did not match his professional experience of natural terrain. The result was not a scientific investigation of the objects he described. The result was a revision of the guidelines governing what he was permitted to include in official documentation. He did his job. The system changed the rules of his job. 56 years have passed. The objects he described are visible in LRO frames published in 2010. The coordinates in the official 1968 documentation and the coordinates in the images do not match. The Brookings report sits in the Library of Congress and says that decisions about whether to disclose information of this type should rest with those who are best able to determine whether to withhold, announce, or release it. The moon is still there. The data exists. The question Blair raised in his memorandum in 1968 can today be tested with precision he didn't have. No one has done that systematically and officially. Not because the data isn't there, because the person who would ask that question officially hasn't appeared yet. The question is waiting. It has been waiting for 56 years. Every year there is more data available to answer it, and still no official question. Just the data, and the silence where the question should be.